In today's lecture, we will discuss about max min question types, problems, in which basically we are maximizing or minimizing one thing. Question relevant to this, but most of the question can be solved using one basic rule, or you can say one basic principle, that when someone asks to maximize one number or one quantity, you need to minimize all of the other numbers. All of the numbers. And likewise, if the question is about minimizing one number, then we need to maximize all of the numbers. So the basic concept is, in this question, you were usually asked to maximize one number. And in case you're asked to maximize one number, you need to minimize all of the other numbers so that you can get the maximum value of that number. And likewise, if you're asked to minimize one number, then you need to maximize all of the other numbers. And for example, if I just give you a case that we have three numbers, and this will be for example, the lowest number. This will be the highest number. And the question could be asked regarding this concept in four ways. That either question will ask to maximize the lowest number, or either question will ask about to minimize the lowest number, so these two are about the lowest. And for the highest, again, there are two cases. Either we could be asked to maximize the highest number, or we could be asked to minimize the highest number, or whatever the quantity is. So these could be weights. These could be, okay. So just remember, usual type of question regarding the minimum and maximum concept, you will be asked to maximize one thing or to minimize the other thing. Or to minimize one thing, remember one thing, whenever you are asked to maximize one thing, just like in this scenario, if you're asked to maximize the lowest number, then in that case, you need to minimize the remaining two. Just like in this example, if you have three quantities and you got three numbers, if you need to maximize this thing, we need to minimize the other two. And likewise, if we want to minimize this lowest value, we need to maximize those two so that we could get a minimum value of the lowest value. And likewise, if we want to maximize the highest quantity, we need to minimize the others. And in last scenario, if you want to minimize this, we will need to maximize the others. And to get an idea about this, let me give you a very basic example. For example, if I say that we have three boxes and the arithmetic, these are three boxes, and the arithmetic mean of these three boxes is equal to 15 kg. So if the arithmetic mean is 15 kg, then we know that what is the average arithmetic mean? That is sum by total number. And we know arithmetic mean is 15, total number is 3. So sum will be equal to how much? Sum will be equal to 45 kgs. So if we add these 3 boxes weights, this will be 45 kgs. Now the next thing given is, for example, if you are given that the median weight is 14 kgs. So that's mean, because this is already arranged in order, this is the lowest one, this is the highest one. So middle one is the median one. And that's why if median is 14, so just place 14 in this. Now the next thing is, if the question asks that what could be the maximum value of the lowest weight, and if the question asks we need to maximize this thing, then how can we do that? The maximum value of the lowest weight could be equal to the median, but this can't exceed the median. If this exceeds the median, our condition that median is equal to, median weight is 14 will not hold, right? So in this scenario, if you want to maximize our lowest weight, that will be 14, and this one is 14. And in this case, we can find the highest weight. For example, this is X. So this is 45. So 28 plus X is equal to 45. And in this way, we can find the highest weight based on the scenario that we have a maximum value of the lowest weight. Based on the scenario that we have max value of lowest weight. Now, let's change this scenario a bit and consider a case that we have 7 boxes now. 1, 2, 3, 4, 5, 6, and 7. And we are given that the average weight of these boxes is equal to 20 kgs. So if average weight is equal to 20 and we have 7 boxes, so sum of these weight will be equal to 20 into 7, which is equal to 140 kgs. And the next thing given is that the median weight, as this is arranged in order. So remember, total number is odd. When total number is odd, just add 1 in this and divide by 2. That number will be the median number. So 7 plus 1 divided by 2, 8 divided by 2 is 4th. So 4th one is the median value. So this is median. And for example, if we are given that the median weight is equal to 30 kgs, so this is 30. Now, if the question asks that, and one last thing, that this is arranged, right? So this is the lowest and this is the highest. So if the question asks that what is the maximum possible weight of the box, which is the lightest? So the question asks if we want to maximize this value, then how that is possible? That is possible. To maximize this, we need to minimize all other. And let's see how that is possible. So let's see the values after the median. We have 3 values and we need to minimize this. We need to reduce this, keeping a constraint that this can't be less than the median, which is 30, right? So the minimum value which these 3 can take, that is equal to 30. This can't be less than 30. In that scenario, the median will change. So the minimum weight for the highest 3 boxes, for the boxes with the higher weight, that will be 30, 30, and 30. Now we are left with these 3. Now we also want to minimize these 2. So what could be the minimum possible value? The minimum possible value is if both of these weight equal to this weight, the lowest weight. So these 2 can't be less than this weight because this is lowest, and these 2 in the lowest term could be equal to this, but can't be less than this. So for example, if I call this X, this as x and this as x. So now this will be 3x plus 4 into 30 is equal to 140. So 3x plus 120 is equal to 140. 3x is equal to 20 and x is equal to 20 by 3. So the maximum possible weight of the box, of the lightest box in this scenario, is equal to 20 by 3 kg, right? And one more thing, there could be another constraint in the question as well. In this question, we are not limited that all of these are integer. The question never mentioned that. Another thing is, if the question use the term distinct, that in that scenario, just like in this scenario, we have 4 times 30 and 3 times x, then this is not a distinct case. But if the question asks about the distinct case, then we can't have the similar terms. So we will see the question in detail, but just to give an idea, if, for example, if all of these are integer, so this will be 31, 32, and 33. If this is x, this will be x plus 1, this will be x plus 2, right? So just keep in mind, when you are seeing the maximum and minimum type questions, read clearly that, be careful that whether the word used in the question are about whether the word used is distinct or could be any value, right? So this is just a brief idea about the maximum and minimum. And now we will just move to the question to just have a better idea about that, how can we proceed. Yes, try to solve this. Just use the concept which we discussed so far. Just one golden rule, which will be used in most of the question: to minimize one, maximize all others, and to maximize one, minimize all others. That's it. Just use that and try to solve this within 2 minutes. Okay, so let's solve this. A certain city with a population of 132,000 is to be divided into 11 voting districts, and no district is to have population that is more than 10% greater. This is the key constraint in this question. Then the population of any other district. So what is the minimum possible? The question asks to minimize the least populated district. So in this question, we have 11 districts, and the sum of population in all of these equals to 132,000. And the question says, consider this as the least, and we need to minimize this. And for example, if I consider this as x, so the constraint is that no other district will have a population that is more than 10% greater. So if this is the lowest, is x, so 10% greater will be 1.1x. So this is a maximum possible. Just like the question says more than 10% greater than the population of any other district. So the maximum, if this is the least, the maximum possible value of population for any district will be 10% greater. And if we want, we need to minimize this, and that's why we need to maximize all of the other 10 districts. So maximum possible population for any of these 10 districts will be 1.1x, 1.1x. So each of 10 districts will have 1.1x population in that. So if we add all of these, this will be x plus 10 times of 1.1x will be equal to 132,000. So this will be x plus 11x is equal to 132,000. So this will be 12x is equal to 132,000. X will be equal to 132,000 divided by 12, which will be equal to this 11,000. So the minimum possible weight of the least populated district is 11,000. Okay, so let's move further. Okay, so now let's move further. This was an easy question, and this is the answer for this question, which we discussed earlier. Now, let's try to solve this question. Just think a bit. This is easy, but you need to think a bit. Try to solve this question now. This is a very interesting question. In this question, you're given that there are 5 candidates: Alexa, Bill, Charlie, Dan, and Ernie. Let's call this A, B, C, D, and E. Vying for student council, and 100 total votes were cast. Everyone received at least 1 vote, and no 2 candidates received the same number of votes. This statement is very important. Based on this statement, we can say that all of these 5 are distinct, right? Because no 2 received the same number of votes. And Alexa won the election with 40 votes, and Bill came in second, Charlie came in third, Dan came in fourth, and Ernie came in the last. So we have 5 candidates, and in total they received how much? 100 votes. And let's call this with the highest number and this with the lowest number. And based on the condition, this is Alexa got the highest number of votes, which is 40. So that's this A, B, C, D, and E. Now the thing is, the question asks, what is the greatest number of votes that Bill could receive? So in this question, we want to maximize this value. We want to maximize this value. Then how can we do this? So if we want to maximize one thing, we need to minimize all of the quantities. So we need to minimize these 3. So now let's see how can we do this. For example, the Bill received B number of votes, and for example, for the E, Ernie receive X number of votes. So I want to minimize these 3, keeping in mind that all of these are distinct. All of these are distinct. If this is X, and remember, vote is an integer, this can't be in fraction. So next possible vote for the Dan will be 1 greater, which is X plus 1. And next possible for the Charlie will be 1 greater, that is X plus 2. So I can write this whole equation as something like X 3X plus 3, this is for first 3, plus B plus 40 is equal to 100. And if I take B on the other side, this will become 3X plus 3 plus B is equal to 60. Now we can just assume one thing, that whatever the votes for this bill must be less than 40, because all of these are distinct. Based on that, so what are the possible votes for the bill? That will be 60 minus the first 3, which is X plus 1 plus X plus 2, which is 3X plus 3, and this whole must be less than 40, because this is vote for the bill, and that has to be less than 40 because of this constraint that we can't have a same number of votes. These are distinct. So based on this, this is 60 minus 40 plus 3 is less than 3x. That means 3x is greater than 23. No, this is minus. 3x is greater than 20 minus 3. That means 3x is greater than 17. This means x is greater than 17 over 3, which is greater than, if you quickly solve this, 5 into 15, 5 plus 2 by 3, which is 5.67. So one thing which we just got this by solving that x is greater than 5.67. As these are integer, so x will be least value greater than 5.67 integer equal to 6. So if this is 6, this will be 7, this will be 8, right? So just add all of these. 6 plus 7 plus 8 plus b plus 40 is equal to 100. If you just add all of these, what is this? 6 plus 7 plus 8. That you can quickly solve this without using the calculator, because all of these are consecutive integers, and for consecutive integers, median is equal to mean. So for this, median is 7, mean will be 7 as well. So sum will be 7 into 3, which is 21. 21 plus b is equal to 60, because 40 will move on the right side and this becomes 60. So based on this, b is equal to 60 minus 21, and b is equal to 39. That's why the answer to this is option A. This is the answer for this question, which is 39. This is a bit variation in the last question. And in this, now the question asks for the least value of bill. Now let's try to solve this question. Think a bit and try to solve this. Now let's try to solve this question. This is exactly the same question, just like the older one, with only one difference, that we need to find the least number of votes for the bill. In the last question, we find the maximum number of votes. So again, we have 5 of these, and these add up to 100. And this is A, B, C, D, and E. I'm just abbreviating the 5 names as A, B, C, D, E. A with the highest number of votes and E with the lowest number of votes, as mentioned in the question. Okay, so A received 40. And the question asks, we need to find the minimum value of this. We need to minimize this. How is that possible? If we can maximize these 3. Okay, so how can we do that? This can be done that, for example, if I assume this as x, and I'm assuming the maximum value of this. So this has to be 1 greater than that, because all of these are distinct and integers. So this will be x plus 1, and this will be x plus 2. And the next thing is, whatever the maximum value of this, that has to be greater than this and less than this. And for now, if I take x plus 3, right? So just add all of these. What will be this? This will be 4x plus 6 will be plus 40 will be equal to 100. So this means 4x is equal to 100 minus 46. 4x is equal to 54, and x will be equal to how much? X will be equal to 13.5. But wait a minute. Instead of using the equality sign, I should use the word less than or equal to. There's a reason for that, because right now I'm assuming these values, and there could be a scenario that this is not x plus 3, this could be x plus 4, this could be x plus 5. But the thing is, all of these must sum to whatever the answer on the right side are less than that, but can't be greater than that. So x has to be less than or equal to 13.5. So based on this, we need to find an integer value which is less than 13.5. So the minimum, the greatest value less than 13.5 is equal to 13. So based on this, if I see these 5, 100, this is 40, this is x, which is 13, this is 14, this is 15. So based on this, we can find this. But if we assume x plus 3 as this is 16, this is not equal to 100. We can see that this is 13 plus 14 plus 15 plus. So what is this thing? 14 into 3 plus 40. Let's call this as, for example, b. plus B is equal to 100. So this will be how much? 12. 42 plus 40 plus B is equal to 100. That's mean this is 82 plus B is equal to 100. So this means B is equal to 100 minus 82, which is 18. So that's why E is answer. But no, we can minimize this a bit further. How that is possible? If we just increase this one time, and for example, if this becomes 16 and instead of 18, this will become 17. So if you add all of these, this will sum to 100. So minimum possible number of votes received by Bill are 17. Okay, now let's move further. So the answer to this is 17. Now let's see another variation in this question. What is the least possible number of earning? You can solve this. This is comparatively easy. You can solve this a bit later. And the answer is 1. Let's see another variation. If we solve this again, we have these 5 and these 5 add up to how much? 100. This is the highest A and lowest one is E. This will be B, C, D. I'm just using the abbreviation of these 5 names. And this is given as 40. We need to maximize this. And for that, we need to minimize other 3. So if I consider X as a maximum value of E, so what is a minimum value of B? That will be 1 greater than this, X plus 1, because all of these are integer and distinct values. So C will be 1 greater than that, and B will be, we need to see whether that is 1 greater or 2 greater. For example, if I consider as 1 greater than that. So now if I add all of these, this will be 4x plus 6 plus 40 is less than or equal to 100, right? And 4x is less than or equal to 100 minus 40 minus 6. 4x is less than or equal to 54, and x is less than or equal to 13.5. Now the thing is, the question asks, we need to maximize this value. So the maximum value of x, which is less than 13.5, is 13. So now let's see these 5. And this is 13, this is 40, this is 15, and these two will vary. This will be 16 or 18, or this will be, this is 14, sorry, 14, 15. So this will be 16 or 70. There could be 2 scenarios for these, but doesn't matter. The thing is, we need to find the maximum value of this E. The maximum possible value of E is 13. This can't exceed. So if I exceed this, because all of these are distinct, this will become 14, 15, 16, 17 plus 40. And all of these, if you add all of these, this will exceed the 100, right? So that's why the maximum possible value in this scenario for the E, the number of votes E could receive, that is equal to 13. Okay. So this was the answer for this question, which is 13. This is a very interesting question. And if you're able to solve this question, you are very much familiar with this concept now. So just quickly try to solve this question. In this question, we are given that 7 pieces of rope have an average length of 68 centimeters. So we have now 7 pieces, 1, 2, 3, 4, 5, 6, and 7. And then average weight is 68. So we know the average, we know total term. So what will be the sum of that? That will be 68 into 7. And what is this? This will be equal to 476 centimeters. The next thing is, we are given a median length of 84. These are 7. The median will be, just add 1 in, because total numbers are odd, just add 1 in that, divide by 2, that will be the median number. 7 plus 1, 8, 8 divided by 2 is 4. So if this is arranged in order, which is already arranged, highest and lowest, so the median is this which is equal to 84. The next thing is, if the length of the longest pipe, this is longest, this is shortest. If the length of the longest pipe is 14 centimeter more than 4 times the length of shortest piece of rope. Okay, this is rope. So if I consider this as x, the length of the shortest piece of rope is x. So the question says the length of the longest piece of the rope. So I can write this as this is the longest. So this will be 14 more than 4 times the length of shortest. Length of shortest is x. So 4 times of the shortest, which is 4x. So we know the shortest now, we know the longest now, and the median now. The question is, what is the maximum possible length in centimeter of the longest piece of rope? We need to find the maximum value of this. So how is that possible? So we need to maximize this. That is possible if we minimize all of these. If we minimize these 6, so how can I minimize this? If this is x, and in this question we have no limitation of the whether these are distinct or not. If there is no limitation, you can consider these as same. So if the first one is x, so for the remaining 3, if this one is x, for the remaining, not 2, for the remaining 2, we need to minimize these 2. What is the minimum possible? If this is x, these 2 must also be x. So these 2 are minimized to their minimum extent. So if this is a median 84 and we need to minimize these 2, so what is the minimum possible value? Keep this thing in mind. This is the median and these 2 can't be less than median. In that scenario, the median will change, which is not possible. So the minimum possible value of these 2 are equal to median, which is 84 and 84. So you add all of these and equate to 476, you will get the value of x. So this will be 3x plus 3 times of 84 plus 14 plus 4x equals to 476. So this will be 7x plus, if you add all of these, this will become around 260 some 6, and this will be equal to 476, and 7x is equal to 476 minus 266. This will be equal to 210, and this means x is equal to 210 divided by 7, which is equal to 30. The question asks the maximum possible length of the longest, which is 14 plus 4x. So this will be equal to 14 plus 4 times of 30, which is 14 plus 120, which is 134. That's why the answer to this is 134. So moving again, just to give an idea, if this is a median and you to minimize the value above this, those could be minimized when these are equal to the median. And as this is the lowest value, you minimize these 2. These 2 could be equal to that, so that these are minimum. So just add all of these, equate to 476. You will find the maximum possible length of the longest piece of rope, which is 134. The answer for this question is 134. This is the same thing. In earlier, we are solving that in the form of what problem? Now these are in the form of variables. You can solve this question as well, and this as well. Yeah, try this question. We are given that if x square plus y square is equal to 100, and both of these are non-negative integers, the maximum value of x plus y. So let's try to come up with easy form so that we can just get an idea about an x and y. This is x square plus y square is equal to 100. So because we need to find x plus y, in case we have x plus y on any side, then this question will become easy. So if I add 2xy on both sides, so this will become x square plus y square plus 2xy, and this will become 100 plus 2xy. And this is actually x plus y square, x plus y whole square formula. So this will be x plus y whole square is equal to 100 plus 2xy. And if I take square root on both sides, this will become x plus y is equal to square root of 100 plus 2xy. So in this, if I want to maximize this thing, that is only possible if we have maximum value of x into y. We have, because 100 plus 2xy square root, and this is 100 fixed value. In case we could get a maximum value of this, then we could have a maximum value for x plus y. And this is only possible if this x square plus y square is equal to 100. If x square is equal to 100, that's mean if x is equal to y. How can we do that? If x is equal to y, that's mean this will be x square plus x square is equal to 100. This will be 2x square is equal to 100. This will be x square is equal to 50. And if we take the square root, the value of x will be something greater than 6 and some value greater than 7. No, greater than 7 and less than 8. So the value of x will be something greater than 7 and less than 8. We don't need to actually know that thing, which I can write this as x is equal to 7 with plus sign. That's mean a bit greater than 7. As x is equal to y, so that's mean x is equal to y is equal to 7 plus. So if I just add x plus y, x and y, that will be 7 plus means something greater than 7. In fact, in decimal, so that will be 14 plus, so some value greater than 14, that will be 14 point something, which is in the decimal. So our answer is greater than 14. That's why the answer to this is quantity C. So the thing is, in this question, if you want to maximize the value of x into y, you need to have very close values for x and y, for x and y. In that scenario, you could have a maximum value of x into y. But in the extreme, if you consider a case like, if you just make this maximum and this minimum, this 10 and this is 0. So if you add x plus y, this will become 10, which is not the maximum. And likewise, if you make this maximum, this as minimum, this will again from 0 plus 10, which is equal to 10, not maximum. So you will get a maximum value when you have a x around approximately equal to y. In only that scenario, you could have a maximum value of x into y. That's why the answer to this is some value greater than 14 and probably less than 19, right? And the answer to this is the option C. This is similar question and you can solve that at your own. Just a quick idea. In this question, we have in the numerator absolute value, in denominator minus x square minus 3. And in denominator, we are getting a negative value. But the question asks for what is the value of y, a value of x, so that we have maximum value of y. So you can solve it your own and get the idea. This is a very interesting question, but due to lack of time, I'm not doing this. And if you have any confusion, we can discuss this in the next coming lecture. Okay. And try this question at your own as well. The second last question. This is a very interesting question. And the last question, this is another common type of question. There are 4 common type of questions in this maximum and minimum concept. And this is one of those question type. And just try to solve this and be quick. Okay, so in this question, we are given that a garden center sells a certain grass in a 5-pound bag. So for 5-pound bag, the cost is around 13.85 per bag, average cost. And for 10-pound bag, the cost is around $20.43 per bag. And for 25 pounds per bag, the cost is $32.25 per bag. If the customer is to buy, okay, so the quantity needed is greater than or equal to 65 pounds and less than or equal to how much? 80 pounds. So we need to find the least possible cost of grass seed that a customer will buy. So in first we have 5 pound and cost is around $13.85 per bag. And the next one is 10 pound and its cost is $20.43 per bag. But if I use this 5 pound to make a 10 pound, so for making a 10 pound out of this 5 pound, I need to multiply this with 2, and that will be something around $27 per bag. So this is on average better than using the 5 pound. Now, if I use a 25 pound, so that is how much? $32.25 per bag. Now, instead of this, if I use twice of this 10 pounds to make a 20 pound, so twice of this 20.43 per bag, so that will be something a bit greater than 40 pounds per bag. So based on all these, the best average price per pound per bag given is for the 25 pound. Well, for making a 50 pound, if I take twice of this 25 pound, which is 2 into 32.25, and this is around 64.50 pounds. So for the 50 pound, I will use twice of 25 pound. Now there could be multiple options available for the remaining. Now let's see few of these, and we will decide at last that what will we use at first. The first one is that if I use another 25 pound to make, and one last thing, I have gathered the 50 pounds, right? For the remaining, I need how much? I need from value, I need further quantity greater than or equal to 15 and less than or equal to 30. So now for the remaining, 20, just give me 1 minute. Okay, so I was saying that I have choose the 50 pound earlier by considering twice of 25 pound because this is better average than remaining other options. Now, if I choose the 50, I have left with 15 to 30 because the remaining I need to choose from 65 to 80. So I already choose the 50. Now left with 50 and 30. 50 and 30. Now let's see several cases. The first case is if I choose another 25 pound. So that will be how much? That will be another 32.25. And if I add this 64.50 and 32.25, this is 96.75. This is first scenario. Now let's see the other scenario. The other scenario is if I consider twice of 10 pounds, and which is how much? $40. So 64.50, if I consider twice of 10 pounds, so that will be how much? That will be 64.50 plus this $40 for twice of 10 pounds. And that is greater than 100. But we can't use this because we have already a better option than this. And the last option is that if I use 1 10 pound and 1 5 pound, so the 1 10 pound and 1 5 pound, that will be how much? 20.43 plus 13.85. And if I add those with this 64.50, that will be greater than our least option which is available, and that is again 96.75. So the idea is you can consider any case provided to you. You will get a best possible option, which is $96.75.